Here we have a customer that mailed over 2 hard drive motherboards. I see one of them labeled as donor board right here, and the other one labeled as to be repaired right here. The customer wrote, I have 2 hard drive motherboards that need chips swapped out from between each board. I will attach photos in another follow-up email, but what needs to be done is there are 2 square chips, one labeled YPM L643AW and another one labeled YPM Q201AW that need to be swapped out from their respective boards. Remove them from their boards and swap their locations. The chips are in their correct orientation when the text is upright and the SATA connector is facing to the left. Again, pictures will be provided. We need an engineer to decrypt what the customer wrote. I'm confused. Should we take chip A and put it on board B and also take chip B and put it on board A? Is the customer going to only use one board, or the whole thing could have been summarized in one sentence? Take the chip from board B and put it on board A. Done. Let me take a look at the board that is labeled to be repaired. What does to be repaired means? Should we keep this board and just swap out the chip? What is the donor board for? I think that's the square chip the customer is talking about, and this one is labeled YPM Q201AW. So the customer wrote that needs to be swapped out from their respective boards. Remove them from their boards and swap their locations. So I think what the customer, I do not want to guess. We're going to take this chip and put it on the other board, and we're going to take the chip from the other board and put it on this board, because I cannot make out what the customer means. I can send them a message and ask him, but it's just going to make the process a lot longer. Okay, I think the idea is clear. He wants the square chips swapped. I'm going to swap both. I'm going to take chip B, put it on board A, and chip A, put it on board B. That's what we're going to do. I'm going to label this board A, and I'm going to label this chip A. Let's use a silver one, A, and A here is good. So right now it looks like pin number 1 is here, the small circle, and not the big one. So that's 32 pins each side, 64, 128. That's a 128 pin chip. So that's board A. I'm going to put it on the side. Let's grab board B, and we're going to label it board B. We do not really need to label it because one board is already labeled. We do not have A, B, C, D, E, F, and the whole alphabet. We only have A and B. So that's the donor board right here. Right? We're gonna do the same thing here. We're gonna apply leaded solder and clean out unleaded. Let's grab chip A and we're gonna put it on board B. I see some bridges going on between the pins. The pins are extremely tight, very narrow, small pitch. So we want to make sure that we do not have any bridges or a short between any one of the two pins. We're going to go over the pins one by one, even though I think all the pins are making a solid connection. We just need to get rid of the bridges. Let's check. Solid. Solid. We have 128 pins. I'm not going to say solid 128 times, but as you can see, all the pins are making a very solid connection. We really do not need to go over the pins. We just need to get rid of any bridges. What I can do is zoom in to those pins so we can see better. For example, we have a bridge here, we have a bridge here, and we have a bridge here. But let's make sure the pins are making a solid connection. Because what good is it if you remove the bridge, but the pin is not making a solid connection? Every single pin is making a very solid connection. And finally, we're gonna check this side right here. Not a single pin is loose. All right, amazing. Now the question is, how are we gonna get rid of those bridges? That's a very good question. We can use our solder braid, or we can attempt to brush off the bridges. Let me see if that will work. I mean, those pins are extremely tight, so trying to clear a bridge can create another bridge. Maybe the best way to go at it would be a soldering iron and a wick. But just for the sake of trying, let's try to use our NF.mini and see if we can do it that way. Maybe I can zoom in more. Like so. The more we zoom in, the more we're gonna introduce shake and vibration. See? Done. I mean, the NF.mini pen is so precise that you can do this pin by pin. Try this with another soldering iron or another tip and see what happens. Like this one here. It's not gonna work. The NF Mini was born for those type of jobs. And that's why if you're a hobbyist or in the same type of business, you know what to do. Just log into our site, NorthridgeFix.com, click on shop, add whatever tools you want or need in the shopping cart, check out, pay, and we almost always ship out same day. You see, we have a big blob here. This one is gonna take a wick and just like that, see? All right, and we are done. Let's go ahead and clean up. And then we can call it off for this repair. We're gonna use Amtech wipes. I'm using 99% isopropyl. People always ask, what are you using to clean? I'm using 99% isopropyl. You can use 97% isopropyl. You can use 91% isopropyl, but do not use 70% because it contains a lot of water. And I'm using Amtech wipes. You can purchase those off our site. Just log into NorthridgeFix.com, click on shop, add to cart, check out, pay, and we almost always ship out same day. I keep mentioning this for all new viewers because we get the questions every single day. Hello, how are you doing? Yeah, if you bring it in, I'll take a look. We are done. We did an awesome job. We're gonna do the same thing with the other board, with the other chip. We're gonna put chip B on board A. This one here, I'm not gonna do it on video because we already did this one. It's gonna be similar. And we're gonna send the boards back to the customer. I hope you enjoyed the video. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe. And we'll do something else in the next video.